Well, students, we now come to another section of electrostatics, which is electric force and Coulomb's law. Well, as we have discussed already, that a charge is nothing but what we call an electrical mass. So we have two charges here, Q1, Q2, separated by a distance, which let us say is R. So in this case, the Coulomb's law suggests that the force is going to be proportional to the product of the charges and is going to be proportional to the, what we say it, inverse square law, proportional to the square of the distance between them. Now this brings us to the main portion of the law, which relates to the constant correlating these two parameters of charge and distance. Now the constant, let us discuss first in CGS system. The constant in CGS system, if we discuss it, taken to be as 1 by K. Now K here stands for what we call it a dielectric constant, where K we call it a dielectric constant. We'll come to know more about dielectrics when we get to the chapter of capacitance, but right now just memorize, just remember, it is nothing but a constant whose value for air is 1. So for air we have its value to be as 1. Now there are many examples, many cases where this constant of proportionality is simply put as K. In that case, you have to remember that the K in this case is nothing but a proportionality constant. But when you put it as 1 by K, the K is nothing but dielectric constant. So this is a very important part that you need to learn, that when we can write it with K, K is just a constant, and we can write it as 1 by K. In that case, K is no ordinary constant, but it is the dielectric constant. In fact, why this is very important is that when you introduce a medium, this constant suggests that the electrostatic force will decrease. Say you have a force of 12 units, you introduce a medium of 3, so your force gets to 4 now. So that is what is the very most important part about the dielectric constant. I hope it is clear to you. When you put it as K, this K will mean nothing but just a proportionality constant. When you put it as 1 by K, K will mean a dielectric constant whose value is 1 for air, and for any other medium the value is more than 1, so your force will decrease if you introduce a medium between two charges. Now let us come to the CGS and the MKS system. Here the CGS system, if I come to the MKS, we have the constant as 1 by 4 pi epsilon naught. Now this force is what we call the force for free space. Now the free space is nothing but the surrounding around us, which was previously termed as vacuum, but vacuum now is related with something else. If a particular pressure is less than that of the atmospheric, we call it vacuum. So now instead of vacuum, we are calling the surrounding as free space, and this epsilon naught is what we call the permittivity of free space. So this is the permittivity of free space, which has a specific value of 8.85 into 10 to the power minus 12. The unit is very important, it is farad per meter. So if you put it as 1 by 4 pi epsilon naught, the value is much simpler for calculation, as it is 9 into 10 to the power 9 meter per farad. So you have to understand that for a free space, you have to apply this force F naught, which I will write again is 1 by 4 pi epsilon naught Q1 Q2 by R square. And now if I take a medium, and if the medium have a epsilon R, well, what we call a relative permittivity. Now this is relative permittivity, and then the force, as we have just discussed, will decrease and it will become F naught by epsilon R. So if I put it together, it will be 4 pi epsilon naught epsilon R Q1 Q2 by R square. Now this product of epsilon naught and epsilon r is what we call the absolute permittivity of the medium. So this is what we call the absolute permittivity of the medium. And as you can see from here, the relative permittivity is a ratio of two permittivities which has no unit. Why? Because these two quantities are having same unit. So the relative permittivity has no unit. Now the relative permittivity again is 1 for air. So many tend to call K, the dielectric constant, as the relative permittivity. So now our equation for air medium remains same as that of free space, which is 1 by 4 pi epsilon naught Q1 Q2 by R square. Now you may question that if the value is same as that of free space, then why we should write it separately for air and free space? Well, there comes the concept, that the very important concept that we have already discussed, that the free space force have this relation with the relative permittivity. When this is 1 for air, these two become equal. But if it is not same, then again it gets to that, what we have already discussed. Your force is now reduced. So again you see, if there is a medium introduced in a field between two charges, if there is a medium between, the force tends to get decreased. This is a very important concept. As for magnetic field, the force increases and there is no such change in gravitation. So now we go on to the next portion of the force, which is related as what we call the vector form of the force. Now what is the vector form of the force is the fact that if I have a charge Q1 here and a charge Q2 there, then this force is actually acting on 1 due to 2. And this force is actually of 2 due to 1. So from Newton's third law, we can put them like this, minus F to 1. And as you can see, if you can put it like them, they mean they are equal and opposite. So now, if we put the vector form of the force, then we can write it simply like this, that F is the constant 1 by 4 pi epsilon naught Q1 Q2. We can put it R cube here along with a unit vector, along with a vector of R. Now this R vector is nothing but the product of mod R and unit vector R. So you see, the force can also be put as 1 by 4 pi epsilon naught Q1 by Q2 R square along with the unit vector. So either you put it in the form of vector or you can put it as a form of unit vector. Mind you, when you put it in the form of a vector, this should be power of R cube. And when you put it in the form of a unit vector, the power should be R square. So why this R cube? Because this R is product of R and R unit vector. So this R, so when I write it like this, R and R unit vector, you see this R and R cube gets cut and it happens to come to what? R square. So this is all about the magnitude of the force as far as Coulomb's law is concerned. Thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.